Okay, lecture tonight is going to be on visualization and on top of what we already did on this subject, we will use a different library that is offering us some more options. Also, we will describe a little bit the process of visualization in general. Before going there, I want to go back for a second on using environments for writing code like Canopy, so those integrated development environments with all the plus and minuses that they can have. So let me go for a second to Canopy. So basically, this is Canopy, as you know. So when you start, you have this welcome note. You have a manager for the package, for the packages, meaning that you can install a bunch of packages. Like in this case, I installed 150 packages, but there are almost 500 more packages available through Canopy. So Canopy has been developed by this company, and they develop an environment. They sort of certify the packages that are in their releases. So not all the packages may be there. So we mentioned to the fact that Python has several thousand packages. If you do the math, we are pretty far from that number, meaning that there are a lot of other packages that you cannot add to your list of packages with Canopy. So, and that's unfortunately is a limitation for this kind of environment. So, for example, Natural Language Toolkit, you also have other issues. I mean, I installed Natural Language Toolkit because it was one of the available packages through Canopy. But Natural Language Toolkit is a sort of suite of libraries. So not necessarily all the libraries are in the release that Canopy is letting you add to your own set of libraries. Also, to install those sub-libraries, you need to go through the Natural Language Toolkit installer. And this is a sort of interactive installation. And this is going to be in a sort of a conflict with the way Canopy is managing the interaction. So the default is this PyLab. The default on PyLab is interactive using Qt4. If you leave the default, Natural Language Toolkit is not going to run as a downloader. So limitations. So I'm not saying that Canopy is bad or is good. It's a great tool for learning Python because it's giving you an environment where you have a bunch of things that you can use at the same time. You have the list of the files, you have a little bit of error checking. So there are some advantages. Um, just to give you an idea, if you want to develop with no one of those boundaries that you have in Canopy, you need to go outside of Canopy. So what I normally do is to use a very basic text editor like this one, that is Sublime Text 2. But any text editor is okay. This one, I mean, has some customization for different languages, meaning that there is a little bit of what Canopy is doing in terms of checking missing parentheses or matching parentheses, like in this case is matching this one with the other, things like that. I mean, minor things. Do not expect huge support. Is a text editor is very basic. So you use the text editor to develop your script, like the one that you have on your screen. In particular, this one is for downloading tweets from Twitter using a library managing the interaction with the Twitter servers. So once you develop your script, then you go to the terminal. That in Mac is a terminal, in Windows is a command line, basically it's DOS. And then you write, like in this case, you can launch exactly that script, write in Python, name of the script with the proper extension. So then you hit enter and it will start. So, and then eventually you will have all the printing just the way you designed your script. So in this case, you have no limitation whatsoever on the packages that you are installing. You are in OpenOcean. I mean, you can download whatever you want, meaning that you can download packages that are not working or packages that are not doing what they are supposed to do. Eventually, even doing something not good for any reason. So they can be sort of Trojan horses. So if you stay with packages that are pretty common, like for example this Natural Language Toolkit, the probability that you will get any form of virus is close to zero. I'm using since several years this approach, and I never got so far any virus or other harmful pieces of code. So again, you do not have to. I'm using Canopy because it's easier, but please do not consider Canopy as the only way to write any kind of code, including Python. So that was, I mean, something not strictly related to the subject of the current class. Let's go to visualization. So we will talk about visualization. It started in the 70s with CAD/CAM manufacturing for cars, planes, chips, all of that. some education, animation, medicine. So, but considering the limitations of the hardware that we had at that time, there was not much that you could do. So the use of graphics and visualization was limited. A decade later, because of the web starting, taking the right momentum, and more powerful computers, you started having some visualization as a sort of a form of communication. If we jump to the current times, we have a sort of use abuse of the visualizations. So in a sense, this visual analytics is a sort of contradiction in terms. If you want to really make sense out of visualizations, you need to consider visualization as the tip of the iceberg of the process of extracting knowledge from data. So you have starting with the data set or the data sets, whatever they are. They can be totally unstructured data, they can be text, they can be visual data like videos or pictures. You apply all the methods for extracting meaningful metrics from this bunch of data that you have, and then you use visualization for representing the metrics. So it's a chain leaving you, the ability to distill somehow the information from the raw data. So the alternative is basically doing just visualization that are a pure representation of the data. They are like histograms on steroids. But basically would be the same thing. So infographics is not real analytics. So it's leaving the analytic portion of the visualization to the person using the visualization. So we are not yet that much in doing the whole process. We will do that. But I want to be sure that the visual portion is presented in the proper way. So visual analytics is the science of analytical reasoning facilitated by interactive visual interfaces. But it's not applied to raw data. So it's applied to a subset of the data somehow extracted and somehow manipulated by intermediate steps of data mining, essentially. So you can use this kind of interactive visual interfaces for synthesize information, detect and discover things that you didn't fully expect. So it's basically a way to interact with the data. In the projects that I do, I generally leave I do all the analysis, I extract the meaningful metrics, and then I have the final data set that is a sort of a combination of initial data and metrics on the data, or a subset of the initial data and metrics on the data. And then on that, I have the layer of visualization. At that point, I leave the client the ability to do some post-processing, meaning client can interact with both some of the data, changing some of the metrics, changing the weight of some of the metrics, things like that, and eventually interact with the visualization itself. So is a post-processing, but there is a base that is basically the final portion of the data mining process before going to the visualization. So visual analytics are not large graph structures with no labels, heat maps with no labels, charts with no interaction. So all of that is more traditional graphs slash visualization. So you can use this visual approach for several reasons. For example, to get the relationships between whole and part. So you can, like in this example, you can discover relationships. You can do sort of exploration on the data using the interaction. You can mix different data types to have a more meaningful information through visualization. You can analyze some temporal data and interact, meaning if you consider a very commonly used way to see what is the evolution of one particular company on the market. So you have the stock value for a long period, and then you can shorten the period to weeks, days, or whatever is the target of your analysis. You can use graphs for supporting reasoning, like a sort of process chart, flow chart. You can use it for creating visual clusters or to detect outliers. You can use it to help you providing labels to data or clusters of data. You can integrate different views, creating a sort of dashboard with interactions between the different portions of the view. Obviously, you can integrate your graphs to create more effective reporting. Before we go into the specific of the library that we are going to use, that is Bokeh, let me go for a second. If we go to the Canvas, so I'm publishing right now the different components of the lecture. So you are going to have the slides, and you are going to have this Art of Knowledge. Let me go to this Art of Knowledge for a second, in particular page 16 and 17. So those are two slides, a few slides extracted from a book that I highly recommend. So the book is this one, Art of Knowledge, anyone can map. I do not have a PDF to share with you because it's just not available. You can buy it through Amazon or other outlets. This in particular is the Kindle version of the book. So over here you will get some directions. I mean, there is no black and white solution, but some directions on what is the most appropriate graph or visualization for your specific need. So if you go I mean, from this page on, you will get some examples of visualizations. And then basically you go a little bit more in details up to this page where you have different categories of needs. So categorization, distribution, trends, composition of objects or text, geospatial location, correlation, relationship, and so on. And for each one, there is a little bit of information what could be the best possible visualization. And it is exactly what you will find in this page that is in the PDF that you will find on Canvas, and obviously you will get the same if you go to the book right here. So basically for each one, so geometric symbol, when you apply what, lines, surfaces, so basically sort of a cross-reference between the needs that we saw in the previous sort of table and the specific solutions that you can apply. So also, I mean, you will get examples. This is basically a sort of a final cross-reference, and that's basically it. On Canvas, you will find also, I mean, this is a link to the book. You will find also some samples of a visualization that are all of those from the same people who developed the book. So basically, you can click on any one just to see some of those quite cool visualizations. So visualization is definitely more than just, I mean, nice pictures. So we want to condensate in one single view data that can be complex. I remember several years ago, MIT worked with the city of Singapore to represent the traffic in the city. And basically, they used a map of the city with the distances changed based on the traffic. Meaning, if there is more traffic, it would take more time to go from point A to point B, meaning that the real geographical distance is actually less because when you have traffic, it will take you more time to do the same distance. Vice versa, you can compact if there is, the zero can be the actual distance, meaning can be only larger than the normal, or is up to you. But basically, this sort of dynamic map of the city was a great way to represent in real time the traffic conditions. And that's one of the many examples. Reality is most of the really cool things that you can do in visualization, you need to use JavaScript or similar languages to do it. With Python, you can do several things, but never as good, as sophisticated as the other. So let me go back to the presentation and let me introduce you Bokeh. That is a library available in Python, is also available through Canvas. Is created by Continuum Analytics. They also have their own release of Python called Anaconda. That is pretty rich. There is, a lot of standard things that are in Anaconda. But you can eventually add external libraries to their basic release. So the reason why there are companies doing that is because Python is an open source software. If you are a company, you want to be sure that the releases are under control. So if there is one release from for one library, all the libraries that are somehow related will be updated at the same time. So if you have no environment, no one overseeing your libraries, you may have trouble at a certain point. So if you go to a company like Continuum Analytics or the one providing Canopy, then they will take care for you of consistencies between libraries, and also eventually add some libraries that are their own, that can be particularly useful in your particular case. Most of those companies started from one specific sector. I don't know, finance. So they developed libraries for finance. And then at a certain point, they decided to leverage on those libraries and create an environment with their libraries that are available only through them. So you basically pay a subscription or any other model, and you will get the release of the so-called standard libraries plus their own libraries. So anyway, Bokeh, developed by Continuum Analytics, that's the even if has been developed by a private company, is available as open source. You can go to bokeh.pydata.org and you will get all the information that you may need. So basically, the idea was to write something letting you do things in a visualization that you normally do using JavaScript. So there are several things pretty nice that you can do using Bokeh. Not necessarily it's easy to get things like I don't know, this one, but it's feasible. So the idea is basically to create graphs that can tell you a story. So novel graphics. So graphics that can tell you something. So on the right side you have the graph, the visualization. On the left side you have the code. So you want to import NumPy because there are calculations to do, and then you want to import some sub-libraries from Bokeh, in particular the plotting one. So then you create basically the numbers that you want to visualize, and then you do show at the end after you create the components of your graph. With show you will have the graph. The different plots can be linked one to the other, like in this case. So if you change one, the other will change. It's flexible, meaning that there are tools inside the visualization, giving you possibilities to do a little bit of post-processing. And it's basically letting you avoid the intermediate step of creating, porting your data to XML for visualizing it through your website. So basically, Bokeh is taking care of creating the graph and extracting an XML, through an XML or a JSON, the HTML for being published in your website or use in any other activities that you do. So, and that's basically what Bokeh is about. Now, let me go to Canopy and see how this Bokeh is working. So we will go through some examples that you will have in your canvas. Right here you have all the samples that I will present in a second. So in this case, we are going to have a plot line. So if I run it, so it generates an HTML, and this is the name. So if we go back to Canopy for a second, so this is the, the name of the file is demo, not much fantasy. I can call it the name I want, and then it will generate as output file this HTML file that we can see with any browser. So over here you can do several things. You can move it, you can zoom in and out, or you can reset everything. You can it's called wheel zoom. So you do like with the mouse, like the scrolling, you can move it and you will zoom it. And that's basically it. You can save it in a different way if you like. So, and that was a very basic graph. So let me go back here. So basically what we did, we first defined the basic characteristics, so the size, width and height, the title, and then we define the values, and then we plotted it. So this is the command for I mean, line is the attribute for the element that we created with figure, that is part of bouquet. So those are the attributes for the function set of functions figured. So basically you define x, y, and the width of the line. If you change this one, obviously you can have a different width. Eventually you can define the color and you may have other options. If you go online to the bouquet website, you will get all the information you like. This one is a circle. Let's run it. So it's basically dots. We can do same things. Again, we can do all the zooms that we want and reset eventually. In this case, just as the other case, a new file has been created. So it's the same name, so we do not see it, but it's the same name. So basically, you define width and height. You define the title, and then you basically define just the same way we did for the other one, the elements that you want to plot. You define, so over here was super easy, was XY line width. In this case, you have XY size of those circles. You can define the color of the line around the circles. And then you can define the color and the size of the labels, if you like. So again, let me run again. So, and that's basically it. Other example. So let's run it first, and then we will go back with the comments. So basically it's a line with the dots that are highlighted. So basically same thing, same name, same values, same P. We have the line that is just like this one, and we have the circles just like this one, or similar. And then you have, basically with show, you have the combination. So, other example, run it first. So this one is a little bit more complex. We have several functions that we are representing. So let me go back here. So we have those values for x, 0, that are the labels over here. And then as y values, we have 3 of them. One is the square of the value in the x-axis. One is this other formula, 10 power x. And then we have this other formula. So those are the values. Then we create, we define the name, that this time is different. We create the figure, so we need to specify a little bit more in terms of attributes. So let me go back here. So those are the attributes that we want. Those tools we can have them or not, but is pan, box zoom, reset, save, pan, box zoom, reset, save. So you may have some of them, all of them. Then you have the type for x-axis, it's log, that's what we are saying. So let me go back here, so log axis example, the title, and that's basically it. So, and then we have all the components, and then there is just one show. I will go a little bit faster on the next examples. This is an histogram. We want NumPy, so we define the data, name the file, create the figure. In this case we are specifying a background, so that's the color that is here. Obviously if you change it in any way, I don't know what we are going to get in this case. So, different color. Not much. And then I mean, you can change the color of the line, the fill color, and all the rest. And then you basically create the components and you show them. So let me jump to something that is a little bit more complex. So you can create something with a certain degree of complexity. So obviously you may need additional libraries to do that, but then you can plot the Lorenz curve, just defining it, and then as in the other cases you define P attributes and show it. All right, so that was basically what I have to say on visualization in Python. This is the probably the last class on something that is not an application per se, but is more giving you another tool that you can use, that is this bokeh. But visualization is a sort of a complex task that is not just a technical one. There is a lot in terms of ergonomics of the visualization, interaction, human being, machine. So we actually offer a course on visualization that is EM 622, and is all semester, or there is also a version condensed in 1 week full time, but is a regular 3-credit course just on visualization, using mainly R for creating those visuals. So that's basically it. Thank you and good night.